So folks, we finally made it to the last section of trig. Congratulations. 16.11 talks about learning how to solve trig equations, and we're talking about a little bit more complicated equations than what you've been doing in the past. So before we get started, we should look at some things to keep in mind. So first of all, you will probably still need to know your trig identities from the last unit. So all of your Pythagorean identities, your fundamental identities, probably not your sum and difference so much, but probably your double angle and half angle identities you'll need to know. You're also going to have to remember all those things that we learned in the first semester, all those algebra skills. So things like factoring and dealing with fractions and cross multiplying and all those different skills that you had to solve equations before. The other thing that we need to remember is that you are looking for every single possible solution that you can get within a given domain. But you also have to make sure that the answers that you're coming up with actually work in your original equation. Because sometimes in the course of solving the equation, you come up with some extra answers that don't actually work in the given equation. So either it gives you an undefined value or it just doesn't work out algebraically. So just keep all of those things in mind when we go to solve. So let's take a look at this first example. We have the quantity of 2 cosine x plus 1 multiplied to the quantity of cosine x minus 1 equal to 0. And this right here is your domain. Now, if they don't give you a domain, then that means you have to figure out every single possible answer, which means consider all the different rotations you can do, which then means your answer should be in set builder notation. Okay, so because we have two quantities multiplied together to give it a 0, using our zero product rule, we know that at least one of these, maybe both of them, have to be 0. So if that's the case, I can take this quantity and set it equal to 0, and I can take that quantity and set it equal to 0. And now I have two very simple, easy little equations to solve. So let's start with this one. I'm going to subtract 1 from both sides and then divide by 2. Basically, I'm isolating cosine x, so that at this point I can look at this equation and ask myself, what angles, when I take the cosine of them, will I get a -1/2 as an answer? So this is exactly what we were doing in the last couple sections. It's the inverse cosine, right? Only because we are going from 0 to 2 pi, we actually get to use all 4 quadrants. So since cosine x is supposed to be negative, we're going to look at the 2 quadrants where cosine is negative, and that's going to be the second and the third. So if you look at your unit circle, in the second and the third quadrant, we would get 2 pi over 3 and 4 pi over 3. So at those two places, cosine is going to be -1/2. So there's half our answer. Next, we're going to go over to this equation, do the same thing, but the only thing we have to do is add the 1 to the other side before we can figure out what angle, when you take the cosine of it, you get 1. So look at your unit circle, and that gets you 0 and 2 pi. Now we do get to use both of these because there are equal signs with our inequalities, so we can have our answer be 0 and we can have it be 2 pi. Sometimes, you got to watch out for this, sometimes there's no equal sign with one or both of the inequality symbols. So just watch out for that. Okay, so we can list out our answers, and typically when we list out our answers, they should be in order from smallest to greatest, but if you just get them all there, I'm happy. Good enough for me. Okay, so there was the first equation. Now, just thinking back, if I had multiplied this all out, if I had used FOIL, right, you would get something that kind of resembles a quadratic equation. So sometimes your equations you're going to look at and you should recognize that it's quadratic in nature, and then your first step would be to factor it so it would look like something like this, so that then you could jump to this step and continue on. So just be aware that's something to look for in your equations that you're solving. All right, let's look at the next one. We have sine squared x minus cosine squared x is equal to 0. And notice here we don't have the equal sign for 2 pi. Okay, so a couple different ways that we could approach this problem. One of them would be if we took this negative cosine squared x and we moved it to the other side, and then we could take the square root and then figure out all the places where that would occur. So that's kind of a bigger look at it, just kind of examining where sine and cosine are identical, plus or minus, notwithstanding. Or algebraically, what we could do is we could replace either this expression or that expression with our Pythagorean identity, the sine squared plus cosine squared equals 1. And that's what I did, is I actually took cosine squared x and I replaced it with 1 minus sine squared x. And then I distributed by negative. I combine like terms. I move the 1 over, divide by 2. And now, because we want to get this by itself and it's squared, we're going to take the square root. And remember to rationalize, and remember your plus or minus, right? So we're looking at all the places where the sign of x is plus or minus root 2 over 2. And those are all going to be the angles that are pi over 4, or use pi over 4 as a reference angle. So that's pi over 4, 3 pi over 4, 5 pi over 4, and of course 7 pi over 4. Okay, so next, moving on. Okay, so once again, numerous ways to solve this. I'm actually going to show you two different ways. And the first way that I'm going to show you involves us taking the conjugate of the denominator and multiplying the top and bottom by it. And when we do that, the denominator becomes 1 minus cosine squared x. And what we can do with that is we can replace that with sine squared, since that's our Pythagorean identity. And then sine and sine squared can cancel, and we're left with this. Now, hopefully, you guys are looking at this and saying, hey, that looks like the half angle identity for tangent, right? So I could say this is actually the tangent of x over 2 is equal to 1. Now, trying to figure out what x values that's going to give you could be a little difficult when this is actually x over 2. So a strategy that you can use, and you'll use this a lot later on in your math studies, is to replace this with a different variable. But you have to let the reader know what variable you're replacing it with. So I'm going to say let x over 2 actually equal theta. So then I could rewrite this equation as the tangent theta equals 1. And now this is kind of easy to look at your unit circle and figure out where exactly is the tangent equal to 1. And hopefully you got these two answers when you looked at your unit circle. But remember, we're trying to solve for x, we're not trying to solve for theta. So the next order of business here is to go back and resubstitute this back in for theta, turn that back into the x over 2, and now I can multiply and solve for x. So actually get x equals pi over 2. So there's one of our answers. Let's do the same thing over here, replace this with x over 2, multiply by 2, and we get 5 pi over 2. Unfortunately, if you look at our domain that we have here, 5 pi over 2 exceeds 2 pi. So we're going to cross that one off, and we just have pi over 2 as an answer. Okay? So that's one way that you could have solved this problem. Let's take a look at another way. So here it is. What I could do is I could square both sides. As long as you do to one side as you do to the other, you're good. So that would give me sine squared over 1 plus cosine, that quantity squared, equal to 1. I can replace sine squared with 1 minus cosine squared. And then this is the difference of squares, right? So I can factor that. And notice that this is 1 plus cosine x. This is also 1 plus cosine x, but it's squared. So these can cancel, right? So I can cross this off and cross off that 2. And now I'm left with 1 minus cosine over 1 plus cosine is equal to 1. At this point, I'm going to cross multiply, basically move this denominator up to the other side. And notice that your 1's are going to drop out. And this, I can move over there. Combine terms, I get 0 equals 2 cosine x. Divide by 2, I get 0 equals cosine x. So that's nice. So let's look at the places where cosine is 0. And that's going to give you pi over 2 and 3 pi over 2. Now, here's the thing. Remember how I said you should always be checking your answers, whether that's a mental check or you actually are physically writing it down and looking at it. If you plug pi over 2 in and you evaluate the sine of pi over 2 and the cosine of pi over 2, you're going to get 1. But if we plugged in 3 pi over 2, you're not. And let me show you why. So here's plugging it in, right? Now, if you look at your unit circle, the sine of 3 pi over 2, that's negative 1, whereas the sine of pi over 2 is positive 1. And we know that the cosine of 3 pi over 2 is 0, so that just goes away and you're left with the 1 down here. But what happens is because the sine of 3 pi over 2 is negative 1, negative 1 over 1 is not equal to 1. So we have to throw that answer out. So get rid of it. And then we know that our answer is simply pi over 2. Okay, congratulations, folks. You finally made it to the very, very end. And hope all is well. Okay. See you later.